All right. Good morning. Good morning, Instagram. Good morning, YouTube. Today we are continuing the SAT Khan Academy problems. We are running right down the line into interpreting nonlinear expressions. As always, I'm looking at these problems for the first time, and that is part of the fun. So let's jump right into it. We're going to solve 5 problems on YouTube. If you're listening in on Instagram or watching on Instagram, you can see me talking about the problems, but you won't be able to see the actual whiteboard. So if you want to see the actual problems being solved live or at a later time, go to my YouTube channel. Just go to YouTube and search for Scalar Learning. You'll find everything there. This will be my most recent video. All right, so let's jump to the share screen. Here we go. Let's begin. Let's take this and throw it up here. Here we go. Here we go. Let's begin. So company manufactures bookcases. The function above gives the costs C in dollars of producing Q bookcases. So here's our this guy. This is actually a quadratic function. I can already tell, even though it's not exactly, but it's sort of like similar to a quadratic function. How many dollars is the fixed cost of production before any bookcases are produced? Okay, what they are doing here, they're trying to get us to understand what this equation means as far as, when we look at all these different components and then this constant. Usually, if we're talking about fixed cost, we're talking about a cost that is going to be there no matter what. It's like the sunk cost or whatever you want to call it. Fixed cost will simply be this constant. We can prove that by thinking, hey, when we don't produce any bookcases, we would plug in a 0 for Q. This guy would go to 0. This guy would go to 0. The cost would be whatever remains, which would be this guy. So our answer for this is pretty straightforward. Should just be 2,000. Let's go ahead and enter that and make sure we are on the right track. And we are indeed. All right, let's go to number 2. So these might not take too long, maybe. Let's see. The next one, number 2. And again, Instagram guys, if you're tuning in now and you want to watch the video, make sure to go to my YouTube channel and you can see it all there. All right, here we go. Number 2. The following equation shows the height in meters, h in meters, above the ground of a football t seconds after a particular kick. This is definitely quadratic. We got an exponent of 2 here, and that's the highest exponent. What was the height of the football at the moment of the kick? Okay, football t seconds after a particular kick. This is the same thing. It's the same question as before. It's just wording it in a slightly more ambiguous way. But what they mean is, what is the height of the kick at time 0, at the moment of the kick, right when it's getting kicked? So we would plug in 0 for t. This would go away, 0 for t. This would go away, and we'd be left with 0.3 meters. Okay, so these are just starting points. This is all about that constant value. Okay. All right. Let's do number 3. You see, again, there's this big emphasis now in the SAT, even more so than before, to have these word problems, to have these interpretation problems. It's very interesting. Obviously, it bodes well for people who are more comfortable with the English language, right? All right, let's look at number 3. Bn equals 2 to the n. So some exponential equation. A binary code word of length n is a string of zeros and ones with n digits. For example, 1001 is a binary code word of length 4. The number of binary code words b of n of length n is shown above. All right, so this is telling us it's like n would be the number, sorry, it's the length of the string. And basically this equation tells us how many different types of words we can form with just zeros and ones of that length. Okay, if the length is increased from n to n plus 1, how many more binary code words will there be? Okay, we can do in a couple examples. Okay, we can, I mean, there's a way to just do this algebraically, but this is the first thing that's coming to my head. we could just do a couple examples. And let's go 2 to the 0. Let's go 2 to the 1. Let's go 2 to the 2. Let's go 2 to the 3. And let's go 2 to the 4. Okay, this would be 1, 2, 3. How many more binary? Oh, sorry, that's not 3. What am I doing? That's 4. Excuse me. This one is 8, and then this one is 16. So you can see it starts to double. So first we have, and actually this would be, yeah. So one word, I guess, if you have no length, actually would be nothing. But anyways, we have one, a length of 1. If there's 2 words, it'd be 0 or 1, and then it goes to 4, then it goes to 8. So it's doubling. Okay. We have so if we're and what they're doing when they say more, they don't give you the option of it doubling. They say how many more binary code words will there be. So we got to now look at this change. We got to look at what is it going up by. 2 to the second has how many more than 2 to the 1? It has 2 more. This one has 4 more than the previous. This one has 8 more than the previous. So isn't this interesting? What's happening here is when it's increased to the n plus 1, a strange pattern is emerging. See, I didn't anticipate this, but what's happening is we're literally increasing from by the amount of choices that there already are. It's basically being doubled, or increasing by that number. So if we go from 2 to the second to 2 to the third, we're increasing by 2 to the second. If we're going from 2 to the third to 2 to the fourth, we're increasing by 2 to the third. So whatever 2 to the n is, that's how much more we're getting when we go 2 to the n plus 1. Now, there's a way to do this algebraically, but this is, or more algebraic, I suppose. This is more like arithmetically, but 2 to the n, that would be your answer. I'm hoping that method makes sense. That was just, again, the way that popped into my head to check this one out, and that is indeed correct. So we're moving on to the next one. By the way, when you see that little icon in the upper left-hand corner, that calculator crossed out, it of course means no calculator. If you're unfamiliar with the test, there is indeed a no calculator math section. It's something you have to be prepared for. Guys, I see there's a few guys watching right now. Again, if you're watching this on Instagram and you want to see the live feed, you want to see the questions, you want to see me see what I'm actually solving, go to my YouTube channel, go to YouTube, search for Scalar Learning, and you can jump on the live stream right now. Got 2 more questions to solve this morning. And if you missed the live stream, just go ahead and the videos will all upload there for you to watch at your convenience. All right, f of t equals 1500 times this 1.045 to the t power. The future value f of t of an investment after t years is given by the function above. What was the initial value of the investment? Once again, 0 is our t value. Initial just means with no time has passed. If we plug 0 in as an exponent, you should know this. What happens? Anything to the 0th power is 1. So that 1.045, goodbye. It just turns into a 1. 1500 times 1, anything times 1 is itself. So our initial value of the investment is just 1500. Let's go ahead and enter that. Let's see if the College Board agrees. And they do. It's amazing. All right, let's do number 5. And again, this one is no calculator as well. No calculator. All right. Final for the morning, and then I got to get going. A shoe manufacturer determines that its monthly revenue RQ in dollars is given by the function defined above, where Q is the number of pairs. What is this? Monthly revenue. Q is the number of pairs of shoes sold each month. What is the maximum value of the company's monthly revenue in dollars? All right. This is a slightly more difficult question. Now they want to find maximum. So this is tough because how do you find the maximum? We're lucky. This is a quadratic equation. This is actually an inverted parabola. I can tell that because it's got a negative slope there, and it's going to go like this. The maximum is going to occur at the vertex. We are lucky, or they've made this problem easy in a way, because they've put this in vertex form. Vertex form is where what's in here is literally this value right here. When you have, it's like vertex form is a times x minus h plus k, where the vertex is hk. So you see what they've done? They've literally put, here's our h right here. So the vertex is 260, 9,500. Okay, that's pretty interesting. If you weren't sure, if you don't know vertex form, you could also look at this problem logically and say this whole thing is always going to be negative, because this part in the squared is going to be positive. It's multiplied by negative 0.31. That quantity is always going to be negative. So when this quantity is something added to 9,500, it's always going to make it go below 9,500. That means 9,500 is the highest point we can reach. So 260 shoes will be the max revenue, but it's not asking the number of shoes. It's asking the maximum value of the company's monthly revenues. Right there is 9,500. So I'm going to go ahead and insert 9,500 into our answer to make sure we're in good standing. Yes, and they concur. Okay, that's it. Let me go back. Let me get off of the screen share here. Oops. Go to this and screen share. Oops. Stop. All right, there it is. So that's it, guys, and I hope that was helpful today, both for peeps on Instagram and all you guys listening or watching on YouTube. Again, I got all sorts of resources and materials, so feel free to check them out. I also got songs and music videos on different math concepts, which have been really useful for a lot of people. So check those out as well, and they're kind of fun too. I just made one on pi. The next one is coming out shortly. Don't know exactly when yet, but I'm already writing and recording, and it's all about special right triangles and coming up with a melody so that people can remember special right triangles really easily. You don't have to think about it. You can just remember the jingle. So anyways, that's fun. That's all I got for you guys this morning. I hope you have an awesome day. My day, I know, is already off to a great start. Now, time to head to the gym. So take it easy, guys.